What's going on, everybody? Got a video here for you, trigonometric integrals. This is for applied calculus class. I've got another video on trigonometric integrals in my calculus lecture, so you can check that one out if you want to. The problems are different in that video, so yeah, take a look at it too if you need some more examples. So let's just go ahead and get started. So let's suppose we have that we're integrating sine to the m times cosine to the n dx. So here's some guidelines to go by to help you do these. If the exponent on the cosine is odd, you want to save a cosine factor. If the exponent on the sine is odd, save a sine factor. And if both powers are even, use these identities here. These are half angle. Well, I don't know why it's doing that. All right, I don't know what's going on with the writing, but I found another color. These are your half angle identities from trig. So keep those in mind. They look different than what you see in the trig books, but these are your half angle identities. And then if we've got tangent and secant, if the power of secant is even, save a factor of secant squared. If your power of tangent, the exponent on your tangent is odd, save a factor of secant tangent. And then let's recall these two integrals. You should know these from earlier in the course. The integral of tangent is natural log of absolute value of secant plus c, and the integral of secant is natural log of secant x plus tangent x absolute value plus c. Now this one right here, keep in mind this, you may also see it as equaling negative natural log of cosine x plus c. Okay, either one. Okay, I don't know which one your teacher shows you, but either one of them's correct. All right, so how about we just go ahead and get started with some examples. So we have the integral secant cubed cosine squared. Now you can see here, you see how we have the sine factor is odd, so we want to save a sine factor. So let's work this out. So we're going to get the integral of sine squared x cosine squared x times sine x dx. So that's what it means when it tells you to save the sine factor. So the sine cube, we take a sine factor out and put it here, and then this now becomes sine squared. So what we're wanting to do here is we're wanting to be able to use u substitution. Okay, so you see this sine x right here, this sine x dx. Well, the derivative of what is sine? Well, we know the derivative of cosine is negative sine, right? All right, so we're going to need to let u equal cosine. But we still have this sine squared here. But can't we do this? Can't we write 1 minus cosine squared x? We can replace this sine squared with 1 minus cosine squared. Okay? See, when I save this factor of sine, I need to get everything else in terms of cosine. All right? And then that's times cosine squared x sine x dx. And so now I can let u equal cosine x, and du is negative sine x dx. So what am I missing? See, right here I have sine x dx, but I need negative sine x dx. So I can multiply by -1 to get the negative sine x. And if I multiply by -1 in here, I need to come out here and multiply by -1. And that's the same thing as multiplying by +1. And so this is going to give me negative 1 minus u squared. So yeah, I'm replacing cosine with u. And then that's times u squared. And then look at this. All of this right here, this negative sine x dx, I'm going to replace with du. And so that's du. And so that's going to be negative integral u squared minus u to the 4th du. And then I think what I'll do, you don't really need to do it, but I think what I'm going to do is distribute this negative. So that's going to be the integral of u to the 4th minus u squared du. All right. So I just went ahead and distributed the negative, so I don't have to worry about bringing it along. So when I distribute the negative, that becomes negative u minus u squared, and that becomes positive u to the 4th. And so now we're ready to integrate. So this is 1/5 u to the 5th minus 1/3 u cubed plus c. And so this is going to give me 1/5. And what are we going to do? In the place of u, we need to put cosine x back in there. So that's going to be 1/5 cosine to the 5th. Well, let me make that a little bit better. Cosine to the 5th x minus 1/3 cosine cubed x plus c. And there's your answer. Okay. All right, so that one wasn't bad. That's a pretty basic one there. It's not bad at all. Okay, so what about this one? I've got cosine to the 5th 2x. So what are we going to do here? Well, for this one, the cosine power is odd. So I want to save a factor of cosine. So I've got cosine to the 4th 2x times cosine 2x dx. All right. So far, it's, I don't know. What could we do with this? Well, I've got this cosine 2x dx out here. But I need to let u equal something. So I would need to let u equal sine, right? Because the derivative of sine is cosine. So I need to get this in terms of sine. So what I could do is I could write this. Well, I don't know how to convert cosine to the 4th. I don't know how to write that in terms of sine. But I do know how to write cosine squared in terms of sine. So that cosine to the 4th, I can rewrite it as cosine squared squared. Okay? And then that's times cosine 2x dx. And now this cosine squared, I can write as 1 minus sine squared 2x squared. Okay? So all I did here is this cosine squared 2x, I replaced it with 1 minus sine squared 2x. And then that's times the cosine 2x dx. All right. So now we can just come up here and let u equal sine 2x. So du is, well, what is that? Cosine 2x times 2, right? Remember, derivative of sine 2x, derivative of sine 2x is cosine 2x times the derivative of what you're taking the sine of, which is 2, and then dx. All right. So now let's replace everything. Oh, but wait a minute, we can't yet, because see, we've got 2 cosine dx, but here I just have cosine dx. So what do I need? I need a 2 right here. So if I'm multiplying here by 2, I have to come out here and multiply by a half. So that is going to give me 1/2 times integral 1 minus u squared. I'm replacing sine 2x with u. And then remember, all that is squared. And then all of this gets replaced with du. And so that's du. And so this is going to give me 1/2 integral. That's going to be 1 minus 2 u squared plus u to the 4th du. So what did I do there? Well, there, let me see, let me get this color here. So what I did, this, remember, this is just 1 minus u squared times 1 minus u squared. Okay, and I just folded it out and got this. All right, so now we can integrate each term. So that's going to be 1/2 times, that's going to be u minus 2/3 u cubed plus 1/5 u to the 5th plus c. And so now I need to substitute, substitute sine 2x back in for u. And so that is going to give me 1/2. I'll tell you, and let's do this first. Let's go ahead and distribute the 1/2. 1/2 u minus 1/3 u cubed, the 2's cancel, and then plus 1/10 u to the 5th plus c. And so that's going to give me 1/2 sine 2x minus 1/3 sine cubed 2x plus 1/10 sine to the 5th 2x plus c. And there is your answer. All right, so it's not too bad so far. They're going to get a little bit more difficult, but other than that, it's not bad. All right, so let's look at this one. We've got sine squared x. All right, so if you remember from the first, hopefully you wrote all that stuff down. Up here, what did it say? It said if the powers are even, we want to use these half angle identities here. And we've got sine squared, so we're going to use this half angle identity. All right, so remember this identity here. All right, so let's come back down here and work through this problem. All right, so this is going to be the integral 1/2 1 minus, and that's going to be what? Cosine 2x dx. All right. So probably what I want to do here, I'm gonna show all the work on doing this one. Okay. And then if we run into something like this again, we'll and I'll kind of explain how we can do this real quick in our head too. All right, so first thing I want to do is I want to split this up. So first, let's go ahead and do, let's say 1/2 minus 1/2 cosine 2x dx. So I just distribute the 1/2, and then that's going to give me the integral of 1/2 dx minus, and I'll go ahead and pull the 1/2 outside the integral for cosine 2x dx. All right. All right, so this one right here, that's easy to integrate. That's just 1/2 x. So let's look at this one. So remember for this one, we've got the 2x here. So we're going to let u equal 2x, du is equal to 2 dx. All right. So the 2x, this 2x right here, that's going to get replaced with u. But then for du, I need a 2 dx. So I need to multiply this by 2, And if I multiply by 2, I've got to come out here and multiply by half. And so this is going to give me 1/2 x, that's integrating that one, minus 1/4 integral cosine u du. We just use u substitution here. Okay, see the 2 dx got replaced with du, and the 2x here got replaced with u. And so this is what? 1/2 x minus 1/4 cosine, I'm sorry, not cosine, sine u plus c. So antiderivative of cosine is sine. And so this is going to give me 1/2 x minus 1/4 sine, and then in the place of u, I'm going to put 2x plus c. And there's your answer. All right. So just look at it this way. Let's erase this part here in red if I can. See if I can get that erased. All right. So this part right here, okay, this part right here, we can actually do that in our head, okay? So, you know, you don't necessarily have to write this down, but if you need to, go ahead and write it down. But all we're doing is, okay, I've got a 2x here. So if I let u equal 2x, then I know du is 2 dx. So you just think in your head, I need a 2 here, and then that's going to have to be 1/2. Okay? And so you know when you integrate that, it's going to be the 1/2 out here, and that's why we got 1/4, and then the antiderivative is sine. Okay? So, you know, if you can, work on doing this part, this u substitution, for the trig functions when you have a 2x or a 4x or a 5x. Work on doing that in your head. And like I said, if you can't do it in your head and you need to write it down, that's fine. But just think of it. Just think of this. Let's just write the integral of cosine. Let's just say 5x dx. So look at this. If I let u equal 5x, then du is 5 dx. So I need a 5 in here. Okay, I need a 5 in here. So that means I would have to come out and multiply by 1/5. And then the antiderivative of cosine is sine. You see that? And even take it a step further and just go c, or maybe not c, maybe a times x, where a is just a constant. Well, what would that be? That would be what? 1/a sine ax plus c. Okay, that's all it is. So it's not difficult to do. But like I said, if you need to do that, that's fine. Nothing wrong with it. Just trying to save you a few steps there. All right. So what about this one? We've got secant is odd. Okay, so hopefully you're catching on what we're doing here. Basically, what we're wanting to do is we're wanting to separate things. We're wanting to let u equal something, and then when we take the derivative of u, we want that to be beside the, you know, in the integral. We need du to be in that integral. So for this one, well, let's just go back up here and see what it says, what we need to save. It says power of secant is even. Save a factor of secant squared. Well, secant's odd. Power of tangent's odd. Save a factor of secant tangent. Well, secant in this problem, tangent is odd because it's a power of 1, right? So let's try that. Let's write secant squared x times secant x tangent x dx. So I've saved a factor of secant tangent. Okay, it doesn't look like we saved a factor of tangent. Well, actually, we just wrote it down again. But let's look at it. Let's look at this. Is there something I can let u equal, and then when I do du, when I take the derivative of that, is that by the problem? Well, let's see. If I let u equal secant x, see we got a secant squared here, well, what would du be? Well, du is derivative of secant is secant tangent. Well, look at that. That worked out nice, didn't it? See, there's your secant tangent dx. So this is just a simple substitution here. So we're going to have u squared, plug u in the place of secant, and then secant tangent dx, that's going to be replaced with du. Well, that was an easy problem there. So that's just what, 1/3 u cubed plus c, which that's just 1/3. And then back in the place of u, we're going to put secant cubed x plus c. And there's your answer. All right. And like I said, the other video I have on this, it's problems like this, but they are different. So, you might want to check that video out. Oh, goodness. Let's see what we got here. We've got tangent to the 5th. So, how in the world are we going to do this one? Well, let's just kind of go through it. My tangent's odd, and what did it say when tangent was odd? It said save a factor of secant tangent. We don't have a secant in here. But let's just think about what we're doing. We're dealing with tangent. We know the derivative of tangent is secant squared, right? We know the derivative of tangent is secant squared, and we know the derivative of secant is secant tangent. So somehow, maybe I need to try to get tangent and secant in this problem. Well, how can I get a secant? How can I get something in here written in terms of secant? Well, we do have a property that says 1 plus tangent squared is equal to secant squared, right? So maybe if I could get a tangent squared up here, so maybe I could write this as what? Tangent cubed times tangent squared dx, something like that. Well, let me write that back down. 1 plus tangent squared equals secant squared. So, well, this tells me that what? That would be tangent cubed times what? Times secant squared minus, secant squared x minus 1 dx, right? Because if we move the 1 over, we get tangent squared is secant squared minus 1. All right. So let's see. What can we do here? Let's think about it. Well, I'm thinking here maybe we need to let's do tangent cubed, tangent cubed x secant squared x dx minus tangent cubed x dx. Okay, distribute the tangent cubed and then split the integral up. Okay, let's try that and see how that works. So this one's going to be okay because here on this one I can let u equal tangent and then du would be secant squared. So that one's fine there. It's this one we need to worry about. So I think what we're going to need to do here is we've got tangent cubed x secant squared x dx minus, I think what we're going to need to do here is do this, tangent x, tangent squared x dx, and I think we're going to need to redo this one also. Let's see what we get. So that's tangent cubed x secant squared x dx. Like I said, we're not worried about this one. We can integrate this one. I'm just going to hold off and integrate everything at the same time. Minus the integral, and that's going to be tangent x times not 1 times secant squared x minus 1 dx. Rewrite tangent squared as secant squared minus 1 again. Now we'll look at this. And so that's going to give us the integral of tangent cubed x secant squared x dx. All right, so let's distribute the tangent here. Okay, so that's going to be minus the integral tangent x secant squared x dx plus the integral tangent x dx. See, I got the minus, and the minus is going to give me the plus. All right, so now, well, let's go ahead and do some u substitution. So let u equal tangent x. So du is equal to secant squared x dx. And look at that. I can actually use that for both of them. You see that? And so that is going to give me the integral of u cubed. See, I'm going to put u in the place of tangent, and then secant squared dx is going to be replaced with du minus the integral, and same here. Tangent's going to be replaced with u, and secant squared dx is going to be replaced with du plus, oh, look at this, we've got tangent x. The integral of tangent x. Well, that's easy. We'll integrate it after we all at the same time. So let's just write it down again. All right. So this is going to give me what? 1/4 u to the 4th minus 1/2 u squared, and then plus natural log absolute value secant x plus c. Remember the integral of tangent x, I wrote that down up here. See, integral of tangent x is this, or you could put minus natural log cosine. Either one's perfectly fine. Okay. Here we are. So this is going to be 1/4, and what do we put back in the place of u? Tangent. So that's going to be tangent to the 4th x, that's a 4 there, minus 1/2 tangent squared x plus natural log absolute value secant x plus c. And like I said, this, you could also write the answer as, let me write it in a different color. You could also have 1/4 tangent to the 4th x minus 1/2 tangent squared x minus natural log absolute value cosine. Let me write that a little better. Cosine x plus c. So either one. However your teacher tells you to do this, but either one's correct. If you're in my class, I don't care which one you write. Both of them's right. All right. All right. So let's look at this problem. We've got cosecant to the 4th 2x. So how in the world am I going to do this problem? Well, there's nothing that we have at the first that tells us anything with cosecant. If you have an odd power, save this factor, and even power, save this factor. But I do know what I'm trying to get. I'm trying to get to where I have let u equal something, and then du equals this, and then I want them both to be in the problem, right? So I can make a u substitution. Well, what do I know about cosecant? Well, I know the derivative of cosecant is negative cosecant cotangent. And I know the derivative of cotangent is negative cosecant squared. Okay? So maybe if I had this in terms of cosecant and cotangent, I could get something done. Well, do I know how to do that? Well, I do remember this identity from trig that says 1 plus cotangent squared 2x is equal to cosecant squared 2x, right? All right, so now what can I do there? Well, I could write this as cosecant squared 2x times cosecant squared 2x dx, right? Just rewrite cosecant to the fourth as cosecant squared times cosecant squared. And then this cosecant squared right here, I'll replace with 1 plus cotangent squared. And so that's going to be the integral of cosecant squared 2x times 1 plus cotangent squared 2x dx. And then I think what I want to do is distribute it. Clear those parentheses and split the integral up. So that's going to be the integral cosecant squared 2x dx plus the integral cosecant squared 2x cotangent squared 2x dx. All right. Now, well, the first one's easy. The antiderivative of cosecant squared is just negative cotangent. And then this one, well, look at this. What's the derivative of cotangent? Negative cosecant squared. So I can let u equal cotangent 2x. So I'm going to let u equal cotangent 2x. So du would be negative 2 cosecant squared 2x dx. And what am I missing? I'm missing a negative 2, so I got to multiply by negative 2. So come out here and multiply by negative 1/2. And so this is going to be the integral. This is going to be the integral of cosecant squared 2x dx minus 1/2 integral. Now let's make our substitution. In the place of cotangent 2x, I'm going to put u, so that's u squared. And in the place of negative 2 cosecant squared dx, I'm going to put du. And so this is going to be, well, what's the antiderivative of cosecant squared? Well, that's negative cotangent squared, right? Negative cotangent 2x. But remember, we talked about this. See the 2 here? That means we'll have a 1/2 out here, right? You can do u substitution. You can let u or since we got u here, you could do w. Let w equal 2x and do the u sub on that if you need to. But I showed you in an earlier problem how we can avoid that. And then that's going to be minus, and then that's going to be u cubed, so that's going to be 1/6 plus c. And so we get negative 1/2 cotangent 2x minus 1/6, and then in the place of u, we're going to put cotangent cubed 2x plus c. And there's your answer. All right. So that one wasn't too bad. Okay. All right. So now, we're here to our last problem. Let's see how this one goes. This looks like a tough one. Okay, so I'm not really sure what I want to do here. This one looks kind of complicated. But one thing that I have learned from trig is sometimes if you want to simplify things, rewrite everything in terms of sine and cosine. So let's give that a try, see what happens. So we got 0 to pi over 4. And so that's going to be sine cubed x over cosine cubed x over 1 over cosine cubed x dx, which that's going to be 0 to pi over 4. And let's see, that's actually sine cubed x over cosine cubed x times cosine cubed x over 1 dx. And then look at that, those cancel out. So we're left with 0 to pi over 4 of sine cubed x dx. Now, so that looks a little better there. So we got sine is odd, so I think maybe we can save a factor of sine. So that's 0 to pi over 4, and that's going to be sine, not cubed, that's going to be sine squared x times sine x dx, which that's going to be 0 to pi over 4 of 1 minus cosine squared x times sine x dx. All right, so let's see, let's let u equal cosine x, and du is negative sine x dx. So we're missing a negative, so multiply by 1, come out here, multiply by -1, and then go outside, multiply by -1. So that is going to be negative 0 to pi over 4. Oh, well, let's do this. That's going to be 0 to pi over 4. That's going to be what? 1 minus u squared du, right? And that is going to be from 1 to square root of 2 over 2. So where did that come from? Well, let's see. Let's do this color. So since I'm changing my variables, I need to change my limits on my integral. So u equal cosine of 0, which is 1, right? Plug the 0 in for x, and that gives us 1. And then u equals cosine of pi over 4, which that's square root of 2 over 2, and that's where that comes from. So remember, I know you had to do this earlier. If you're watching this video, you've done that. And so this is going to give us negative, and you know something, I think I'm going to go ahead and do this. I'm going to go ahead and write u squared minus 1 du from 1 to square root of 2 over 2. Just distribute that negative there. And so this is going to give me 1/3 u cubed minus u from 1 to square root of 2 over 2. And so this is going to be 1/3 times square root of 2 over 2 cubed minus square root of 2 over 2 minus 1/3 times 1 cubed minus 1. All right, so, you plug all that in, and then hopefully, your teacher lets you use a calculator on the test, and you will end up with 0.00, no, not 2 zeros, don't write down 2 zeros, 0.0774. All right, just had to make sure I wrote the number down right here. If I didn't, somebody leave a comment, well, you didn't do that right. Okay. All right, so that's the video. That's trigonometric integrals. They're a little more complicated than what you've been doing probably. But hopefully you get the idea of them. Basically what you want to do is you want to be able to let u equal something, and then du needs to be in there also. Okay. Now, that wasn't the case every single time, because remember that one time we had it, what was it? It was sine squared, I think we worked. And when we did that one, we just used half angle identity. Okay. But for the most part, that's what you want to do. Let u equal this, and then you want du out there. That's what you're trying to get. Okay. Now, is that the 100% every single time way? There might be a couple exceptions, okay? But you've got to know your trig identities and be able to just, change things up. All right, so I hope that video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.